Hi, in this video and the next video, I'm going to show you how to use your calculator to find probabilities for binomial probability distributions. Now in these videos I'm going to focus on the mechanics of the calculation and not so much on the concepts, so it would be helpful if you have some basic familiarity with binomial distributions, and even better if you've worked a few problems. Well, let's start by taking a look at the formula. This is the formula for calculating probabilities when you have a binomial probability distribution, and the formula takes three inputs. The first input, n, is the number of independent trials, or the sample size. P is the probability of success, and x is the number of successes that you're interested in finding the probability of. This is a slightly complicated expression to have to enter in your calculator many times. Fortunately, your calculator has a couple of functions with this formula programmed into them, and that's what I'm going to show you how to use. I'm going to go into the distribution menu, which is the second or shift function over the vars key, and then I'm going to well, first let me say that if you're on the 83 model calculator, this menu is going to look a little bit different than what you see here, and that's because the 84s have one additional function in this menu, and that's the inverse t function that you see here. All that means is that the keystroke shortcuts I'll be using will be a little bit different than the ones you would use on an 83. Now I'm going to arrow up to get to the bottom of the menu, and then I'm going to continue up to get to Binomial Cdf and then Binomial PDF. Now you'll note that my keystroke shortcuts that I'll be using for Binomial PDF is the alpha character A, and on the 83s it would be 0. But I've got it highlighted, so I'm going to press enter to put it on the main window of the calculator. Now this function encompasses the formula that I just showed you, and it takes the same three inputs, n, p, and x. To show you how it works, I'm going to do an example. Okay, so here's the setup. In 2008, among students who were enrolled at Front Range Community College and taking classes primarily online, 80% of them were enrolled part-time. Now suppose we randomly select 10 students taking classes online. The question we might be asked is this: what's the probability that exactly 6 of those students are enrolled part-time? Now your first task whenever you're given a problem concerning binomial distributions is to identify the two defining characteristics of that distribution, and by that I mean n and p. Now in this case, in this example, our sample size n is 10 and our probability of success is 80%, because we're defining success to be selecting a student who's enrolled part-time, and that occurs 80% of the time. Our question gives us the x value that we're interested in, and that's x equal to 6. So now I've got the three inputs I need for computing the probability. So I'm going to go back to my calculator and enter those values. And how I do that is to give it n, comma, p in decimal form, comma, x. Now when I press enter, I get my result that the probability that exactly 6 of the 10 students will be enrolled part-time is about 8.8%. You'll note I didn't need to close the parentheses when I entered that function, and you generally don't need to close the parentheses. The only time you need to would be if you've got more than one of these expressions on your command line, and then you press enter. So if you've got more than one on your command line, make sure you close the parentheses. Now let's go and do another example. The next question I want to demonstrate is this one. What's the probability that no more than 2 of the 10 students are enrolled part-time? No more than 2 translates into x values of 0, 1, or 2. And by the addition rule of probability, to compute the probability that x can take any one of these three values, I need to compute the probability of each one and add them up. And so the quantity I'm looking for is this sum, p of 0 plus p of 1 plus p of 2. Now my strategy here is to compute each of these individual probabilities and then sum them together as I go. So let me go back to the calculator and show you how to do that. I'm going to go back into my distribution menu, and I'm going to retrieve the binomial PDF function using the keystroke shortcut, which was the alpha character A, and the A is over the math key. So that puts binomial PDF on the main window. Now I give it the inputs, as I mentioned before, n, comma, p, comma, 0 is the first quantity, and I press enter and I get my result. Now I want to add on the next probability, which is the probability for x equal to 1. So I'm going to press the plus sign, and what that does is it brings down the previous result and allows me to add to it. So again, I'm going to go back into the distribution menu and grab my binomial PDF function, and you can see the real value of the keystroke shortcuts when you have to do that. This time my x value is 1, and then I press enter, and now I've got the sum of the two probabilities. Now I'll do that once more for x equal to 2, and then I will have the sum of all three probabilities. And I get my final result, which is about 7.8 times 10 to the negative 5. So let me take a moment here to point out a couple things about this. The first thing is, when you're computing these probabilities, a lot of times what's going to happen is your result is actually going to be in scientific notation and not floating point decimal notation. And how you'll know that is that you'll have this exponential term on the end of the number, e to the negative something. Okay, so your clue is, if you get a probability that looks like it's greater than 1, look all the way over to the right side of the number, and you're going to see the exponential on the end of it. Remember that a probability can never be greater than 1. So if you see a number that looks like it's greater than 1, then what you've got is an exponential. The other thing I wanted to point out is that when you're doing calculations in this way, where you're doing intermediate steps to get to a final value, you never want to stop and write things down and then rekey them back in to get your final answer. And the reason is that when you write things down and rekey the numbers back into your calculator, you're going to be introducing round-off error. And as you can see, these probabilities are very, very small numbers, and they're going to be sensitive to round-off error. So let your calculator hold these values for you and do the summing for you as you go. The other reason is, when you stop to write things down and rekey them back in, you're more likely to make a mistake when you do so. Okay, one last thing I'll point out here is another way to do this particular calculation is you could do them all in one command line. 3 different binomial PDF expressions added together in one line, and then you'd press enter. And that would work too. The only reason I didn't do it is when you're entering so much information in one command line, it's easy to make a mistake and mess up the whole thing. So I find it's a little easier if I do it in steps, and then I can be a little more careful about getting my inputs right. Okay, so the last example I want to demonstrate for binomial PDF is this one. What are the probabilities P of x for all of the x values in the distribution? And so in this example, those would be the x values from 0 up to and including 10. And you can do this very easily in one step on your calculator. So let me show you how to do that. I'm going to go back into my distribution menu and again grab the binomial PDF function. I'm going to give it n and p for this example, but I'm not going to give it x, because I'm going to compute the probabilities for all of the x values, not just one. Now this command, if I enter it, will spit out all of the probabilities. But what I want to do is to store those values someplace where I can go back and look at them. So I'm going to press the store key, and I'm going to direct the output into a list, and I'm just going to arbitrarily choose list L2, for example. Now when I press enter, what happens is it computes that whole set of probabilities and stores them in list L2. Let's go into the list view on the calculator to take a closer look at the output. The first value in the list corresponds to the probability for x equal to 0. And the next one is for x equal to 1, and so on down to the last entry in the list, which is the probability for x equal to 10. So you can see it's generated a list of 11 probabilities for this distribution. So this is a really great way to answer any kind of question where you've got to fill in a table of probability values. Okay, so that was the last example I wanted to do demonstrating binomial PDF. The next video is a demonstration of the function Binomial Cdf, which works much the same way, but also includes a summing step. So it allows you to compute probabilities for ranges of x values in a single step. But I suggest that you spend a little time getting familiar with Binomial PDF, as it's a quick and easy function to learn how to use. And then you can move on to Binomial Cdf, which is slightly more advanced.